Welcome to a lesson on determining mass using triple integrals. The mass of an object is the quantity of matter in an object regardless of its volume or other forces acting on it. So for example, if you leave the planet Earth, your weight would change, however your mass would not. And if an object has uniform density, then the mass is equal to the density times volume. However, if a mass has variable density, we can still determine the mass using triple integrals. Density given by a density function rho, which looks like this p, then the mass is given by the triple integral of the density function integrated over the region D, where D would represent the boundaries of the solid. Let's go and take a look at an example. We want to determine the mass of the solid in the first octant bounded by the plane 2x plus y plus z equals 6 and has the density function rho of xyz equals 0.5x. So the density is going to be equal to the triple integral of our density function. I'm going to go ahead and write this as 1/2 x. And now we need to decide on an order of integration for differential v. Let's go ahead and use dz, dy, dx. So we'll start with determining limits of integration for z. We know our solid is in the first octant and it's bounded by this plane. So the lower limit of integration for z would be 0, and the upper limit of z would be determined by this plane written as a function of y and x. So if we solve this equation for z, we would have z equals 6 minus 2x minus y, and that would be our upper limit for z. To determine the limits of integration for y and x, let's go and take a look at the xy trace. Remember, we determined this by setting z equal to 0, so we'd have the line 2x plus y equals 6. So we have an x-intercept of 3 and a y-intercept of 6. The limits of integration for y must be expressed as a function of x, so we do have to solve this equation for y. We would have y equals 6 minus 2x. So y starts here at 0, and then it goes up to the line, again expressed as a function of x. So for the limits of integration for y, we would have from 0 all the way to 6 minus 2x. And then for the limits of integration for x, the interval would be from 0 to 3. So the value of this triple integral will give us the mass of this solid with density given by this function. So we'll integrate 1/2 x with respect to z, that'll be 1/2 xz. Now we'll replace z with 6 minus 2x minus y and then with 0. And then when z is 0, this would be 0. Let's continue this on the next page. Let's go ahead and distribute. So we'll have 3x minus x squared minus 1/2 xy. Now we'll integrate with respect to y. So 3xy minus x squared y. Here we'll have 1/2 x times y squared over 2, or minus 1/4 xy squared. Now we'll replace y with 6 minus 2x and then with 0. So 3x times 6 minus 2x minus x squared times 6 minus 2x. Here we'll have 1/4 x times 6 minus 2x squared. Let's go ahead and FOIL this here. We're going to have 36 minus 24x plus 4x squared, and then we're going to multiply this by 1/4 x. So we'll have 18x minus 6x squared minus 6x squared plus 2x to the third. Here we're going to multiply this negative 1/4 x times this trinomial, so we'll have minus 9x, so it'll be plus 6x squared, and then here we're going to have minus x to the third. Let's go ahead and combine our like terms. We're going to have 1x cubed minus 6x squared plus 9x. And now we'll integrate with respect to x. We'll have 1/4 x to the fourth minus 6 times x to the third over 3. That'll be minus 2x to the third. And here we'll have plus 9/2 x squared. Evaluate this at 3 and 0. And then when x is 0, we'll have 0. Here we're going to have 81/4 minus 54. Plus here we're going to have 9 times 9 is 81/2. This gives us 27/4, which is equal to 6.75. And again, this would be the density of the solid. So again, this would be the density of the solid in the first octant, bounded by this plane here with the density function given here. I hope you found this example helpful. Thank you for watching.